Okay, so checking this out. If our cylinder has 90 cubic centimeters, what would the cone with the same base and height have? Who would like to share? Sean?
30 centimeters.
How do you know that?
Because it took 3 cone scoops to fill
Yeah.
the cylinder.
3 cones of the same base and height would fill the cylinder, just like in our demonstration with that old cereal. Number 2, if the volume of the cone is 120 cubic centimeters, what is the volume of the cylinder? Cam?
Would it be 40?
I like where you so.
I got it.
I think a little visual would help here. We're going from cone to cylinder, so you want to make an adjustment?
360. It would be,
No, okay, we're good. It's a good mistake. So if I'm going from here to here, how many times bigger is it?
3.
Okay, so give me something 3 times more, man.
What?
Give me the volume that's 3 times more then.
What 20 times 3 is?
You got it.
So it would be
360 cubic centimeters. Way to stick with it. Good mistake. You're not the first person to make that mistake today, just so you know. That's awesome. So, number 3 then. What is an equation we could come up with? Meredith?
Is this like equation for the cone?
Yeah. Because we know that this one is area of the base times the height, or pi r squared h. Same thing, right?
Yeah, you could do 1/3 times pi r squared h.
Okay, or 1/3 area of the base times the height. Same thing, right? There's another one that's the same equation, only different. Anybody write something that's like pretty similar down?
I did.
Yeah, what did you do different?
I just instead of doing 1/3 in like first, I did volume equals pi r squared times height divided by 3.
Yeah, these are the same thing. Yep. So multiplying by 1/3 is the same thing as dividing by 3, right? Multiplying by the reciprocal. Cool. So those are the equations you're going to want to be ready to use today. This one or this one. This one's the same thing. So I use the same, I like that area of the base visual, where if I get my base and fill it in, and kind of thing. So I use the big B for the base. In this case, the base is a circle, which is pi r squared. Setting this up, friends. For the air, or for the volume of the cylinder, I'm a big fan of starting right here. Okay, I'm a big fan of starting right here. Area equals pi r squared h. Not area, volume. But I'm a big fan of starting right here. Like, this is saying this is the equation I need. I'm going to get my circle and multiply up, and then I fill in with the information I know. It's like a little more writing. I'm sweating profusely from writing that right now because it was such hard work. I'm being sarcastic. It's not actually that hard to do, right? When kids are like, oh, I don't want to do that. Anyway, what's the radius of that?
5.
5, and the height is 4. So then I plug in all the pieces I know. And if you were to do this and do something wrong, I could look at this and tell you what you did wrong. If you wrote 400 pi, I would have to figure out what you did if you didn't do this, right? Like, I could make an assumption maybe, but if you had a wrong answer and you didn't have this step, I wouldn't know what you did. So 5 squared I have to do first because the order of operations is 25 times 4 is 100 pi cubic units. Now, some people kind of overdid this next part, but it's not wrong. I need a third of that. A third of 100 is 100 thirds.
Yeah, that's right.
That's the exact answer. 100 thirds is way easier to multiply or divide things by than a decimal that goes on forever, okay, or even a mixed number. This is ready to use in computation. I'm going to switch to another color for this cone. So the area of the base of this cone is what I asked first. That's pi times the radius squared. If I simplify that, I get 36 pi square units, because it's area. And to get the volume, I need to do 1/3 of what the cylinder would be and multiply by the height. Now, you can use the commutative property of multiplication here, and you can multiply by 1/3 by anything that you want to first. What's the easiest thing to multiply by 1/3 first, do you think?
Definitely
Definitely 36. Like you could do 36 times 8 first, but then you got a big number to divide by 3. So I'm going to do a third of 36 first, which is 12, and 12 times 8 is 96. So you can switch the order you multiply because the commutative property of multiplication. All right, number 3, I'm going to do even a different, I'm going with this one. I would have called this one flamingo. We've got a cone. There's no picture here. I like a picture. So this cone is a popcorn cup. So I'm gonna draw it like this because gravity. Man, that's a pretty okay cone.
Nice cone.
It's a pretty okay cone. Okay.
Looks like chops.
So it has a radius of 5. So I'm gonna write that right there, and a height of 9. Now, one important thing to say is the height of a cone needs to be perpendicular to the base. This, if you get this measurement right here, that has got a really fancy term called the slant height. We don't know how to get that yet. In a couple weeks, you'll be able to use the slant height to do this, but not right now. So how many cubic centimeters of popcorn can this cup hold? Well, I like to start with my equation. I know it holds a third of the cylinder with the same base and height. So that's what I'm starting with, 1/3 pi r squared h. My radius is 5. My height is 9. So, again here, I'm multiplying my third by stuff. Is there a thing I can multiply by a third first that would be easier? The 25 or the 9? Which one?
9.
The 9. What's a third of 9? 3. And then 3 times my 25 is 75 pi. But so this one, you know how I like keeping it exact. On this one, to understand it, it makes more sense to get the decimal. So I'm going to do 75 times 3.14, and I get 235.5 cubic centimeters of popcorn. Nice. All right, a few minutes as a table, I want you to check out this one. Now, what I want to point out is, what they're telling us here is the volume is 64 pi. So the difference here is we're not finding volume, we know the volume. And what they're saying down here is the volume, 64 pi, it equals the equation 1/3 pi r squared times 3. The thing we're missing now is the radius, but we have enough information. If you have everything but one thing, you can always find the one thing using math, okay? So it's your challenge right now to try to tell me what is r. Sean was looking at this equation up here, and he said there's a part of it I can compute. So what could you do, Sean?
1/3 times 3.
1/3 of 3, which he said is 1. So I rewrote it as this. Because 1 times anything is just that thing because of the identity property. Okay. So I need pi, whatever the radius is, I need it to equal, pi's gone, I just need it to equal 64. So what does the radius have to be to equal 64? It has to be 8 because the square root of 64 is 8. Guys, this is the warm-up, by the way. People just saw a cone and freaked out.
Yeah, they were
Well, look at that. That was slide. This is the warm-up. I'm going to go over the second row with you. So if the radius is 1/3, what is the diameter? 2/3. So if it's a circular base, that is pi r squared, which is going to be 1/9 pi. 1/9 pi. Pi r squared. So, next thing. This is where it gets a little tricky. I need to multiply my base times my height, but I also need to multiply by what? 1/3 because I'm rocking a cone, right? So here, I need to do 1/9 pi times 6 times 1/3. We have options here. We can multiply anything by 1/3 first. Does anything pop to say multiply me by 1/3, please? Multiply me by 1/3. Yeah, Van Devin. 6, because 1/3 of 6 is 2, and 2 times 1/9 is 2/9 pi. So you could multiply 1/9 by 1/3 first. You'd have 1/27. And 1/27 times 6 is 2/9. It's just look for an opportunity to make it easier on yourself using the commutative property if you can. Your table's job is to try to fill out the rest. All right, let's fill out this table. So looking at the top, if the radius is 4, what is the diameter?
8.
8. Pi r squared would give me 16 pi. Now I have 16 pi over 3 I can multiply by 1/3 first. Which one's a little nicer? 3. A third of 3 is 1. 1 times 16 pi, 16 pi. This all comes from volume is equal to 1/3 pi r squared h. That's our equation, right? So looking at the next row down, if the area of the base is 144 pi, and I used pi r squared to get there, what would the radius have to be? 12, because 12 squared gives me that 144. If the radius is 12, what's the diameter? 20. The diameter is 24. So now I'm going to take the area of the base times the height times the third.
Yeah.
What looks the easiest to multiply together first?
12 and 1/3.
I'm going to need to multiply this, and 1/3. So I actually personally like multiplying 1/3 and 1/4 together first. What would that give me? 1/3 times 1/4, what would that give me? 1/12. And what's a 12th of 144 pi? What's 144 divided by 12? 12. I better show you that off to the side. I chose to multiply those together first. That's just divide by 12 then, right? So 144 pi divided by 12 is 12 pi. Okay, look at the next one down. I know my diameter is 20, so what's my radius?
10.
So pi r squared would be 100 pi. So I need to multiply 100 pi by what to get to 200? Well, no. I need to multiply by 2. So how am I using a height and 1/3 to make 2 happen? 6. A third of 6. So let me communicate that. I knew I needed 100 pi to become 200 pi, right? And I know I needed to multiply by 1/3. So how do I get 1/3 to be 2? Times 6. Right? That's how, yeah, there's more to think about there. So next one, if the height is 12 and the volume is 64, what would the area of my base have to be?
I would say that would be
So here's what I'm gonna undo times the height times 1/3. So I'm gonna divide by 4. Sorry, divide by 12. What would that be? How do I undo times 12?
you could times
Divide by 12. So what's 64 divided by 12?
or you could multiply. I think divided by 3 or times 3.
Okay, let's do times 3 first. What's 64 times 3? Divide that by 12. 16 pi. So we're just undoing the times. We're doing divide. But just know to divide by 1/3, you're multiplying by 3. All right, if it's 16 pi, what does the radius need to be? 4, and the diameter has to be 8. Last one. We got 3.14 for the volume. Interesting. So I need to undo stuff here. The height is 3. So another way you can think about it is volume equals 1/3 pi r squared times 3. So what's 1/3 of 3? 1. What do I need to multiply by pi to get 3.14? 1. So this has to just be pi with a radius of 1 because 1 squared is 1 and a diameter of 2. All right, home stretch here, friends. I'll leave this up here a second. Now I want you to tell me which popcorn is the better deal. I want you to pay attention to the organization you're about to see, all right? So I know I need the volume. And this one, the volume needs to be 1/3 pi r squared h. This one needs to be volume equals pi r squared h. So I'm going to put in my radius, which is 6, in my height, which is 19. On this one, I'm going to put in my radius, which is 4. and my height, which is 15. And this is just going to give me my volumes, which doesn't tell me anything, actually, in terms of a deal. So 6 squared times 19 times 3.14 divided by 3. This one gives me 715.92 cubic centimeters. 16 times 15. Stay with me. This one gives me 753.6. So the cylinder holds more, but that doesn't tell me what my deal is. Here's what I've got to do. I got to find a price per cubic centimeter. Because you don't know what the deal is otherwise.
We can get more for less on the.
Okay, on this one.
You don't even need to. You don't even need to use the price. Tell there's more. You get more for less because the cylinders. No, guys, that's the price of the dollar.
So what's the better deal?
The cylinder.
0.9 cents per cubic or 0.8?
I think I'm gonna go with
0.8 barely though. Like you don't know it's a better deal unless you math that thing. You can't just eye that for 0.1 cents. Cylinder's the better deal. All right. Homework's on Canvas. Get after it.